All right. Hey, everybody. We are going to start factoring today by talking about greatest common factors. So, if you recall, if we say something like 10 and 25, right? Back when you guys started talking about fractions, you talked about what's the greatest common factor of these things. And basically, the answer was what number can I pull out of both of them? So, for example, here, our GCF is a 5. If I pull a 5 out of here, I know that's 5 times 2. And if I pull a 5 out of here, we know that's 5 times 5. Right? So they both have a greatest common factor of 5. We're going to do kind of that same idea, but we're going to do it with monomials and binomials and trinomials and all sorts of polynomials and kind of figure out what they all have in common. So let's start with, let's start with 8x and 14. All right, so if I have 8x and 14, and I want to know what's the greatest common factor here, what can I pull out of both? In fact, why don't we make this the binomial? So we'll do 8x plus 14. And what I want to do is, so remember, we were just multiplying like a monomial through here. Now we're going to pull it back out. We're going to do the reverse of that. We're going to take it, we're going to take them back, and see what we get when we pull stuff out of here. So first thing I'm going to check here, I can look at these variables. Now 14 doesn't have a variable, so I know that x is not something that I can pull out. But that's definitely could be part of a greatest common factor, is what kind of variables are in both numbers. So that's something we want to check for. And then I'm looking at 8 and 14. So they don't have much in common, but they definitely have a 2 in common. So what I'm going to do is I'm going to pull out a 2, just like it was reverse distributive property. And what would 8x have been before I multiplied it by, or what could it have been before I multiplied it by 2 to get 8x? So kind of like, what is 8x divided by 2? And that would just be 4x. And you can quick check here, right? 2 times 4x is 8x. And then same thing with 14. What did I multiply 2 by to get 14? Well, 14 divided by 2 is going to give me 7. So if you look at these two expressions, they're actually equivalent expressions. This one would have been, if I distributed it, this one is called factored form. We factored out its greatest common factor. So this 2 we took out, that left me with 4x plus 7. And now we call that, it's a factored form. We took something out of it. That was what it would be before I multiplied this 2 through. Let's do that with something a little bit more interesting. So let's say we had something like 32 x to the 4th minus 4 x squared plus, 16x. All right, now we have this trinomial. And if I want to factor this, again, I have to find factors, that don't only just work with 2 terms, but they have to work with all 3 of the terms. So you might kind of have gathered this, but as you get more terms, it's a little bit harder to get a greatest common factor because they all have to have something in common. So I always kind of like to look at my x's first, my variables, what's going on. Well, here I have 4 of them, here I have 2 of them, and here I have 1 of them. So how many do they all at least have? They all at least have 1. So I can pull an x out of this number. Just 1, because they all have at least 1x. But that's not all, because I can look at those numbers in front, the coefficients, and see if they have a GCF. Do they have a greatest common factor? Well, 32, 4, and 16. 4 is a pretty small number already, so there's not much that can go on there. 2 definitely goes into all of them. Does 4 go into all of them? Absolutely it does, right? 4 definitely goes into all of those. So what we can do is we can take out a 4x. And then we just have to write what would be left after I suck this 4x out of all of these numbers. So if I do 32x to the 4th divided by 4x, well, if I took 1x out of here, there's only 3 left. 32 divided by 4, that's going to give me 8, right? And then 4x squared, again, I took 1x out of here, so there's still 1 left over. And if I pull the 4 out, there's nothing, just a 1, right? So just an x. Or you could write 1x there, and it'd be the same thing. And then I pull this x out, so there's no x's left in this number. And 16 divided by 4 is going to give me 4. So here is the factored form of this trinomial. If we took a 4x out of it, now we're left with this. And as you can see, that part of it cannot be factored anymore. Well, from what we know, right now, there's definitely no GCF that goes with it. So we just kind of are good to go there. Now, sometimes you might think you have the greatest common factor, but you don't. So maybe you want to check when you're done, like, hey, do these things still have anything in common? Because they definitely could. You want to be careful about that. So kind of check that out as you go. Let's do one that's fun. Yeah. Let's go. (24) a cubed b to the 4th plus 48 a to the 5th b squared minus, and we'll just go 60 a cubed b cubed. Cool. So now we got a lot of stuff going on right now. It looks like, yeeps, you probably don't really want to deal with that. But it's not so bad. It's the same idea no matter how many terms I have, no matter how ugly those terms look, I'm still doing the same thing. So I'm going to start with my variables and check how many of each one they have in common. If you want to think of it this way, there's this thing called expanded form, right? So a cubed is really just a times a times a. B to the 4th is b times b times b times b. If you can't see it with the exponents, write it out. And then circle how many they all have in common, right? So circle 1 from each one, see how many they have left, circle another 1 from each one, see what's left. So if I look at my A's, there's 3 of them here, there's 5 of them here, and there's 3 of them here. So it sounds like they all have at least 3. So I'm going to pull 3 A's out. So a cubed. And then I'm going to check the B's. There's 4 of them here, there's 2 of them here, there's 3 of them here. So they all have at least 2. So we can pull out a b squared. And then we just check the coefficients. So 24, 48, well 24 goes into 48, and negative 60. 24 doesn't go into 60, but 12 does. 12 goes into all of those. So let's pull a 12 out. And, man, sometimes you guys are going to be like, I have no idea what these have in common. I get that. Especially if your number sense isn't as strong as maybe you want it to be. You're just going to have to mess around with some stuff. Do you remember doing factor trees? Maybe. That's a really good way to find GCFs. See, factor all the numbers with factor trees and then see what they have in common. That's your GCF when you multiply those numbers together. Otherwise, you can always just play with the calculator. right? Sit there and divide, see what divides evenly into it, see if it divides into everything else. See if the numbers you have left are still divisible by something. Usually once you get a little bit smaller, it might be a little easier to tell. All right? So we're going to pull out this 12. And now is the fun part. So there's no A's left. We pulled all 3 out. We pulled out 2 B's, so there's still 2 B's here. And there's 24, but we pulled out a 12. So 12 times 1 is 24. That'd be 2. So my first term is just 2b squared. Same thing over here. We pulled out 3 A's. Well, there was 5, so there's still 2 left. There's 2 B's we pulled out. There's only 2 B's in there, so there's going to be no B's in this number. And 48, we divide that by 12. We get 4a squared. And then the last term over here, we pull 3 A's out, so there's no A's remaining. We pulled 2 B's out, so there's still a B over here. And then 60 divided by 12 is going to give me 5. So if you look at my trinomials, see how much easier that is to work with. After we pulled this GCF out, now these numbers are a lot smaller, which are going to really help me out when I have to do something like factor again, or something like that. So that's factoring with the greatest common factor. Basically, it's reverse distributive property, like I kind of said that earlier. You know, it's going to be just one of those practice things. Let me know if you're struggling with anything, right? Come to office hours on Mondays and Wednesdays. I know this is like probably the most important area of the whole year for us. So if there's something you're not getting, you definitely want to make sure that you take it upon yourself, go after that, and try to figure it out. Come talk to me, send a remind, send an email. All right? All right, that's all I got for you. You guys can go try your practice. Later.